Okay, we're going to continue on. We're still using the neutral atom, and I'm going to kind of show you the differences between this and a nuclear symbol. So we got AS, which is element number 33, and your mass for arsenic on the periodic table is going to be 74.92. Let's see, 92160. Now, if we're doing our atomic structure, again, we're going to do neutral atom, positives, neutrals, and then my electrons. Again, 33. And since we're still dealing with the neutrals, that's also going to be 33. And then I'm going to use this mass number of 75. And then figuring out neutrons, it's going to be 75 minus 33. Your total is going to be 42 as far as your neutrons. I'm not going to do the boron. It's kind of redundant as far as what we're doing. If I wanted to compare this to something called a nuclear symbol, it's going to be AS. Your atomic number is actually going to go down here. I would just say, remember that's going to be the lower number because the mass is always going to be higher. And then I got a 75 up here for my mass number. So they make it sound like it's something really difficult, but it is actually called a nuclear symbol. That is what a nuclear symbol is. Let's go ahead and do another one. Now just remember that when we're doing ions and isotopes, those symbols are actually going to be shown on it. So let's go ahead and do another one. Let's say I'm going to do, let's go iodine. That's element number 53. It's a little larger atom. It's going to look like this. These are going to be my positive protons, which is going to be 53. And then if I'm doing neutral atom, again, this is 53. My neutrons, well, I'm going to have to round this number, which goes to 127. Again, can't use the decimal. So it's going to end up being 127 minus 53. So you're going to have 74 neutrons. Neutrons generally tend to be more than both the protons, of course, and also the electrons. So you can kind of look at this one being the higher number if you're kind of looking at a trend. If it isn't doing that, then just make sure you're checking correct process. This one, since it's a little larger atom, I'll go ahead and do the Bohr, which is 53 positive protons. And I've got 74 neutrons since they make up the whole mass. I got 2 electrons here. I've got 8. Keeping track, I've got 10, 18. I've got 18 more than I'm using, 28. I still got to go to 53, but I also know the maximum I can hold is 32. So if I'm going to do that, I'm going to look at 28. I've got more I have to put in here. You're actually going to need 25 more electrons to make it equal to your protons. So we got 25 electrons here. When you add up all these numbers here, you can use a calculator. It's got to match your protons because, again, we have a neutral atom. If I want to draw this out as a nuclear symbol, this is what it's going to look like. Lower number on the bottom, again, atomic number, and then the mass numbers up here. You don't have any other numbers you can use, so that would be what you're going with. Let's go one more, and then we're done. Let's go with a nice simple one. And then I can kind of throw in, with that simple one, what an ion isotope sort of one's going to look like. But in this case, now I'm just going to go ahead and use the nuclear symbol. And let's go with a positive 1. Now on the next one, when you start looking at your ions and your isotopes, they are going to go the same process. You don't really have to change a whole lot. All you're going to have to know is that my positives are going to be losers. So that's going to lose 1 electron. If I do my atomic structure, again, I'm doing an easy one, so it's not overwhelming. I'm going to use my atomic number, which is 1. I would just do it in order. Then I know this is going to be my mass number. Another way to look at this is I can just go ahead and subtract these two numbers, which is now 2 for my neutrons. It is an isotope because it has more neutrons than it normally has. And then I'm going to lose 1 electron or a negative off of this positive charge. Well, if I lose an electron off of this, what is it going to equal? Well, 1 minus 1 is 0. And where do you get your positive 1 charge? Well, I've got 1 positive, nothing here, so my overall charge is going to be a positive 1. 4 atom, 1 positive proton, 2 neutral neutrons. That makes up the mass of the atom, which is 3. And then I have no electrons, so basically that's what's going to be. And they actually call this, with that type of thing where you have 0 electrons, a bare atom, because it's bare naked as far as your electrons.